Hi everyone. In this video we'll go through few more examples and find derivative of functions using first principles. Let's take this function cot x. We need to differentiate cot x using first principles. So what does this mean? Y is equal to f of x is equal to cot x. Basically y is equal to cot x. We'll have to differentiate. So dy by dx is equal to limit, we'll use that formula, limit delta x tending to 0, f of x plus delta x minus f of x upon delta x. F of x is equal to cot x. So what is f of x plus delta x? Instead of x, we'll put x plus delta x. So it's going to be cot of x plus delta x. So I'll write this as limit delta x tending to 0. F of x plus delta x is cot of x plus delta x. What is f of x? Cot x upon delta x. Now what is cot x? Cot x is cos x by sin x. So we'll substitute here. So we'll get limit delta x tending to 0 cos of x plus delta x by sin of x plus delta x minus cos x by sin x upon delta x. So this is going to be, I can either take LCM or cross multiply. So if I take LCM or if I cross multiply, that is I cross multiply like this. So I'll get sin x into cos x plus delta x. I cross multiply this and this minus cos x into sin x plus delta x. By sin x plus delta x into sin x, we have to multiply the denominators. So we'll get sin x plus delta x into sin x by delta x. So either you can take LCM or cross multiply. Now if you observe, this is of the form sin a minus b, compound angle formula, where x is a and x plus delta x is b, right? X is a and x plus delta x is b, right? This is of the form sin a cos b minus cos a sin b is nothing but sin of a minus b. So now if I substitute this, I'll get sin a minus b. Sin a minus b. A is x minus b. B is x minus delta x. Basically x plus delta x is b. Since it is minus, minus x minus delta x. X and x will get cancelled. Now let me write the rest. The denominator is sin x plus delta x into sin x the whole by delta x. Now you can assume that there is 1 over here, right? And I can shift this on top. If I shift this on top, what's going to happen? It's going to be reciprocal. It will be sin minus delta x. So I'll put minus outside. Minus sin delta x by sin x plus delta x into sin x, and this is going to become reciprocal, right? It's going to become 1 by delta x. There are multiple terms here. I can apply limit to each of these terms, right? Let me split it. I can write it as limit delta x tending to 0. If you notice here, look at this and this. This is of the form limit x tending to 0, sin x by x is equal to 1. So we can use this formula here, right? You can use the theorem. So I'll split this. I'll write it as sin delta x by delta x. Let me put minus here. Into limit, I'll split it of what we have left. We have this 1 by sin x into limit delta x tending to 0 into 1 by sin of x plus delta x. Basically, I've splitted all the terms here, right? We can directly do it. Just to avoid the confusion, I have splitted it. Delta x, this one is nothing but 1, right? So this is 1 minus 1 because minus is here, into, here it's 1 by sine x. There is no delta x here at all. So we'll simply copy it like this, 1 by sine x, right? Limit for this particular term is as is 1 by sine x itself because there is no delta x here to substitute, into, here I can substitute delta x as 0, right? So I'll get 1 by sine x plus 0 is nothing but x. So I'll get minus 1 by sine square x. Sine x into sine x is sine square x. What is 1 by sine x? 1 by sine x is cosec x. Cosec x is 1 by sine x. We can write this minus cosec square x dy by dx. So I can write this as d derivative of cot x with respect to x is minus cosec square x. Now let's try to differentiate secant x using first principles. So what do we have to do? Y is equal to f of x is equal to secant x. So we'll write the formula dy by dx is equal to limit delta x tending to 0 of f of x plus delta x minus f of x upon delta x. F of x is equal to secant x. F of x plus delta x is equal to secant x plus delta x. Instead of x, I'm putting x plus delta x. That's all. So I'll get limit delta x tending to 0 secant x plus delta x minus secant x by delta x. Now I can write what is secant x? Nothing but 1 by cos x. So I'll write this as limit delta x tending to 0 1 by cos of x plus delta x minus 1 by cos of x by delta x. Now I'll take LCM or cross multiply, right? So I'll get limit delta x tending to 0. If I take LCM will be cos x plus delta x into cos x. That is both these multiplied. Both these multiplied would be the LCM. Now to get this as the LCM, I have to multiply this with cos x. I have cos x plus delta x. I have to multiply with cos x. So I have to multiply numerator with cos x. And here I have to multiply with cos x plus delta x. Cos x plus delta x. So with what should I multiply cos x to get this as the denominator? X plus delta x. Cos x plus delta x. So 1 into cos x is cos x minus 1 into cos x plus delta x by delta x. Now if you observe, this is of the form cos c minus cos d. What is cos c minus cos d? Cos c minus cos d is minus 2 sine c plus d by 2 into sine c minus d by 2. So this is the trigonometric formula, right, based on transformation. Instead of c, we have x, and instead of d, we have x plus delta x. So this is c and this is d. So we will substitute. We'll get minus 2 sine c plus d by 2. C is x, d is x plus delta x by 2 into sine c minus d by 2. That is x minus delta x by 2 by, let's copy the rest, x plus delta x into cos x by delta x. So this is nothing but limit delta x tending to 0. This will become 2x plus delta x by 2. Here x and x will get cancelled. So we'll write this as minus 2 sine 2x plus delta x by 2 into minus sine delta x by 2. Here it's minus delta x. I'll bring minus outside. So sine minus delta x is nothing but minus sine delta x by 2 by cos x plus delta x, cos x plus delta x into cos x by delta x. Now I can assume that there is 1 over here and then I shift it on top. I take the reciprocal now. So what will happen? Limit delta x tending to 0. This will be minus 2 sine 2x plus delta x by 2 into minus and minus, I'll make it as plus, into sine delta x by 2 by cos x plus delta x into cos x, and this will become reciprocal. So delta x by 1 will become 1 by delta x. Now, if you notice this portion and this portion, right? I can use the limits theorem, right? What does it say? Limit x tending to 0, sine x by x is equal to 1, right? Sine x by x is equal to 1 if I apply limit. But here I have delta x by 2 and here I have only delta x. So I'll multiply and divide by 2, right? I'll multiply and divide by 2. So I'll get this form, right? So now let me apply limits separately. Limits for this portion, right? And then limits for this portion and this portion. Let me apply limits separately. So I'll get limit delta x tending to 0. I'll bring 2 outside. So I'll get 2 into, I'll just copy everything, 2x plus delta x by 2 into 1 by cos x into cos x plus delta x. And here when I apply limit, it's going to become 1 and I have 2 left over. Now to apply limit here, what I have to do? I have to substitute delta x as 0. If I substitute delta x as 0, it will become 2 into sine 2x plus delta x, 2x plus 0. So 2x by 2 into 1 by cos x into x plus 0. So cos x itself into half. 2 here and 2 here will get cancelled. This 2 and 2 will get cancelled. So I'll get sine x into 1 by cos square x. Sin x by cos x is tan x, right? I have cos x into cos x. Sin x by cos x is tan x. Then I'll be left with one more cos x. So I'll get tan x into secant x. So I can see this as d by dx of secant x is equal to tan x into secant x. Therefore, derivative of secant x is tan x into secant x. Let's find the derivative of 1 by x, right, with respect to x using first principle. So we'll take y is equal to f of x, which is equal to 1 by x. You have to find derivative of this particular function. dy by dx is equal to, let's write down the formula, limit delta x tending to 0, f of x plus delta x minus f of x by delta x. So delta x tending to 0, f of x is 1 by x, f of x plus delta x is, instead of x I'll put x plus delta x. So I'll get this one. So let me substitute. So this will be 1 by x plus delta x. F of x is 1 by x by delta x. Now let me take LCM here. So what is that I'll get? I'll get limit delta x tending to 0. If I take the LCM, what will it be? It will be x plus delta x into x. Now to get this denominator, what should I do here? I should multiply x plus delta x with x. I have to multiply with x, but I multiply the numerator with x. So I'll get 1 into x is x minus, here again I have x here already. I have to get x plus delta x here, right? So I have to multiply into x plus delta x, but I multiply the numerator into x plus delta x. So I'll get 1 into x plus delta x, and the whole, then we'll have to write this delta x here, right? We'll have to copy this. So we'll get limit delta x tending to 0, x and x will get cancelled. So I'll get minus delta x by x into x plus delta x by delta x. Now I can assume that it's delta x by 1, take it up. So I'll get limit delta x tending to 0 minus delta x by x into x plus delta x. When I take this up, it's going to be a reciprocal. So it will be 1 by delta x. So this and this will get cancelled. So I'll get limit delta x tending to 0 minus 1 by x into x plus delta x. So now I'll apply limit. So I'll have to substitute delta x as 0 here, right? That is how I apply limit. So if I substitute, I'll get minus 1 by, instead of delta x, I'll put 0. So I'll get x into x plus 0, which is x. Nothing but minus 1 by x square. This is dy by dx. This is nothing but derivative of, what is y? It's 1 by x. So therefore, derivative of 1 by x with respect to x is minus 1 by x square. Here there are standard functions or the basic functions, and the derivatives of each of these functions is given here. We will have to by heart these derivatives in order to solve the problems. So there is derivatives for trigonometric functions also. We'll have to by heart all of this. We have derived many of these basic functions using first principles in the previous video and this video. With this, we have come to the end of this particular topic. If you like this video, do press a like and share it. Thank you.